Hybrid Cloud Show, Episode 2. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours, and not those of our employers. Before we get into it, how about a quick plug for your newsletter, Shane?
Yes, so I've got a newsletter on platform engineering if anyone's interested in subscribing. It's a monthly newsletter on varied topics regarding tech, developer productivity, and the like. It's monthly, so it's called Platform Engineering Monthly, but I didn't want people to type that out, so it's on pemonthly.com if you want to check it out.
We'll put a link in the show notes. So some time ago, Redis adopted a dual source license. They replaced what they were doing before, a BSD 3 clause, I think it was, with a new pair of licenses. Both of them are source available licenses, but restrict the ability for service providers to offer Redis as a service. Now, in response, we have seen Velki be launched as a fork, and it's supported by AWS, Google, Oracle, and I think also Ericsson.
I think it's really tricky because Redis surely must have seen this coming, that the project would just get forked. I mean, we saw this with Elasticsearch being forked to OpenSearch. We saw this with Terraform being forked to OpenTofu. It's not as if this isn't a well-trodden path at this point. You close the source of your thing or move it to SSPL or something like that, and it just gets forked because ultimately the community don't like it and the cloud providers like it even less.
I think they might be taking a leaf out of an even older project that was forked, which is Mongo. MongoDB went public, and I believe they changed the terms of their license. And they've actually financially done really well off the back. Not necessarily of that, but they definitely have a pretty compelling product atlas themselves. And it hasn't really hurt them financially changing the license terms.
It's interesting, isn't it, with Mongo? Because with these other ones, I can think of the new fork that has taken over. With Mongo, all I can think of is the Mongo Community Edition. Is there a different cloud-provided one as well?
I guess I'm thinking of DynamoDB not being a necessarily drop-in replacement, but definitely like an equivalent product.
Yeah, DocumentDB is one that's pretty close as well.
It's certainly nicer, isn't it, if you can maintain that portfolio where you have the name recognition from the other version sort of reinforcing that people should come to you and pay you for the commercial version that you're trying to sell. So that feels like a much nicer balance to get into, but there's a real risk here that Redis gets a bit left out when these forks take over instead.
I mean, they're trying to sell a managed version of Redis, and they're competing with the likes of these cloud providers who are just repackaging their product. So you can kind of see the motivation, but it sucks still.
The winners here are the cloud providers because they already have their managed offerings that they can sell. And it doesn't matter if it's backed by Redis today or KeyDB or Valky, whatever, because at the end of the day, it's just going to be under their title, right? Whether that's Elasticache or memory store or whatever it is. And they can just swap the back end out and their customers won't know. And that's the whole entire point of why you use cloud resources.
Absolutely. I think the Elasticsearch OpenSearch change was a drop-in replacement. I don't even remember doing anything for that migration, so for sure.
Yeah, I think you'd have just got it in an upgrade. One day it became OpenSearch. And I think it changed name in the console about 3 times, which was an interesting journey. But yeah, ultimately, right, don't you say, Sean, this stuff is just abstracted away from you. 1 minute you're using Elasticache with Redis behind it. The next minute you're using Elasticache with Velki behind it. And as long as that is transparent to you, you just have a connection string that you're putting in, and that's all you really need to worry about. It's kind of the beauty of it, right?
Exactly right. So let's hope that these companies continue to be good stewards of the Valky project, and let's see where it goes.
Yeah, I think the key thing is going to be looking at it in 5 years' time. Do we see the state of the project being pushed forward by this group of AWS and Oracle, et cetera, are they pushing the state of the art forward over that 5 years? Or is this really just maintaining things how they were so that they continue to use it in their infrastructure? And I think that's going to be the real test. Which of them in 5 years' time has moved things on?
I guess the other thing to think about though as well is the contributions from those cloud providers to the Redis project are now presumably going to jump ship to Valky. So you've lost actually a good percentage of your contributors to Redis. So I worry they're going to start stagnating on their end with the brain drain going on that. I think LWN.net had an article and someone had done some analysis, and about 20% of the contributions were coming from Redis employees. There was more coming from Tencent than Redis. So that's something they're going to need to figure out if they want to compete.
Wow, that's going to hurt.
So the next article that we came across was called IAM is the worst. And I think, Shane, you had some comments on how this one played out.
Yeah. So for context for anyone, IAM refers to identity and access management. So essentially it's how you give various entities access to your cloud real estate. It might be like a developer who wants to manage some systems, or it might be a server that needs to operate on some resources in the cloud. The assertion that IAM is the worst, I'm not entirely in disagreement with. There's lots of challenges to IAM. It's not always very consistent amongst the cloud providers, and it can be inconsistent within the cloud provider. I think the assertions, and there's a lot of them in there around where IAM falls down, are understandable. But I think the thing I was more worried about in reading this article was the solution put forward. So what they're suggesting is, rather than figure out ahead of time what the permissions, say, your application needs, what you would do is just deploy the application to production and just let it run for a couple of months with God mode access, essentially. So give it access to everything, and in 3 months' time, we'll have a look at the logs and we'll go, oh yeah, this is what it needs. It needs A, B, and C. Cool. Now, ignoring the glaring security nightmare, which it is, it's also, you're giving something God permissions at a time when you should probably be the most risk averse, which is when you're deploying a new piece of software into your cloud real estate. But it's not just security either. An application developer might put in a dodgy line of code and the blast radius is much higher now because you haven't put any restrictions in place. And as well, like once you've given that kind of God mode out, it's very hard to bring it back. Like they say, yeah, in 30 or 90 days, we'll review this and remove the global access. But the world changes in that time. Like during that 90-day period, permission changes might have happened countless times on that application, which is now running in production and is business critical. The time to figure out how this thing works and let it fail is when you release it, because there's lower expectations. But to say 3 months in, oh, let's review the security of this thing, business may not have an interest in that anymore. It's been working fine. It's stable. And what happens after those 90 days, right? What if the system needs to change and you need to add more permissions? Do you just give it God mode again and figure it out later on? It's purported to be an obvious solution, but I see a lot of problems with that when it hits the real world.
Is there an obvious solution to it?
I think there's a couple of options you could do. I was thinking about this because it isn't an easy thing to do. But the first thing you could do is just get a platform engineering team. When I read this article, it screamed, we're missing platform engineering. It's like application developers don't know how IAM works and it's too complicated, and who would they even submit a PR to? Like that's why it read like this is missing platform engineering. So for context, I guess platform engineering, it's about having a dedicated team that sort of builds shared deployment and management tools for the engineers in that company to build on top of. So how it would work in this example is your application developer builds his app. He gets all the IAM permissions he needs in an AWS account that's completely isolated. He proves that his application does what it needs to do, and then you hand that off to the platform engineering team. They then extend the platform tooling to support whatever this new set of features is, and you abstract it all away from the developer. So the developer doesn't need to think about IAM or anything else. The people who know IAM the best will be the ones responsible for figuring all that out. And you'll have built a solution that's reusable for anyone else who has the similar compute needs at that organization. So that was the first thing I thought of. The other option you could do, if you can't afford a pile of engineers to fix this problem, is you could deploy this to an isolated account and then have the engineer who's built this application do some sort of automated, ideally, or manual black box testing against this service and figure out and watch what permissions it needs. I think if an application developer comes back and says, I don't have confidence that these tests will prove out all the permissions that this system needs, then I would say they don't have any meaningful confidence in the code they've written, which to me says that IAM and lack of understanding of it is a symptom of a larger problem, which is that your engineers are testing in production, which goes back to if you're in an organization doing that, giving it God mode permissions is probably not going to be the best move.
Yeah, I mean, I'm going to come in as a strong flavor and say that if you're writing an application and you don't understand what things it's calling, you're not being a developer properly. But maybe that's a little bit too far. And it's a tricky one because if you don't understand the platform that you're deploying the application into, then you've got a real problem there in terms of writing integration tests and everything else, right? It's much deeper than just IAM permissions, I think.
If we're just scoping this to application developers and the applications they're deploying, then I think those are totally fair criticisms. But we can't expect application developers to also be DevOps and SRE and know how every single other thing they're trying to deploy also works and all of its capabilities.
But what if I'm a full stack developer, Sean?
I am a full stack developer, and that is why I spend my free time running Kubernetes at home so I can learn exactly how to do that. But not everyone has that ability.
See, I always end up approaching this, and I think this is part of like working in a consultancy role from the other end, where I'm auditing something that people have already got deployed, and they've given it this God mode access. I guess they followed this obvious solution that you see in the article where they've just gone, I don't know what it needs. I'm just going to give it S3 star or EC2 star. And that's clearly never a good solution, right?
But they've got a calendar entry for 3 months where they're totally definitely going to revoke it.
Because that will definitely end up back in a sprint and given the right number of story points. And yeah, a product owner will definitely prioritize that. So yeah, I spend a lot of time walking people through using these auditing tools like IAM Access Analyzer and GCP role recommendations. And by and large, what you find is that either one of two things happens. The application actually only needed like S3 get object or something. And someone never figured out that all they were doing is pulling an item from a specific bucket. Or, and I think this is maybe one of the points you made, Shane, is that the application is like spawned off and is doing all sorts of weird stuff that you think it should never do. There's stuff I've seen where for some reason someone's like polling the EC2 metadata service once every minute to see what instance type they're running on in a Kubernetes cluster. It's like, no, you don't do that. You use node taints for that. But then going to get that fixed in code is like never a priority and is arguably even less of a priority than someone going back and running the audit in the first place. So you will sort of end up in this spiral where someone's just calling like a metadata service for an instance every 5 minutes. You don't want to turn it off because you don't know the application code as a platform engineer and you don't know what that's going to break. So you end up in this catch-22 position where it's like, do I just leave it with permissions to do this? Or do I not? Or where am I left at that point?
It feels like there's a bit of a difference between an application writer or developer who is understanding the sorts of conceptual things their application's trying to do. But I do have some sympathy for the argument in here that when you've got literally thousands of roles or literally thousands of permissions that you can choose, that the definitions of those and how one of them differs from the other does get quite cloud specific. So I have some sympathy for an application developer who does understand what their code is doing, but doesn't understand how that maps onto the particular cloud permissions.
But again, that's where platform engineering comes in, right? Is that you have someone who does understand that within the team. And I think this is perhaps where the DevOps model came in, right, and has some value, where you have a team that has a developer in, has a tester in, also has some kind of cloud engineer in who understands the way that your application should interact with it, understands what the application's doing, all the rest of it. And as much as I hate the term DevOps engineer, because it's a really, really broad term, perhaps putting someone in an application team who understands that stuff does have some value.
So the Register's put out an article saying that the UK government's ability to negotiate billions in cloud spending is curbed by vendor lock-in.
It's an interesting constraint to operate under working for a government organization. You have the benefits of the cloud being negotiated in this contract, but are they all expected to be mindful of future changes in government and changes in cloud strategy or strategy in general in compute? Do you make your project slower by being vendor agnostic as much as possible? Is that a more ethical way to spend engineering and tech budget?
Well, I think in this case, you're talking about public money. So I think that, yes, on a personal level, if you're spending public money, you should be spending it in a way that is responsible and reduces duplication of effort. So perhaps locking yourself into a single cloud provider isn't the type of thing you ought to be doing. But equally, I kind of see the benefit for doing that for quick delivery of projects and things. So as much as I'd like to say public money, public code, and therefore public money, keep it vendor agnostic, I don't really have as much of a catchy slogan as the FSFE do. It's a really tricky one because, like you say, Shane, there is a real balance between burning developer hours and therefore public money and salaries, and locking yourself into a single vendor where perhaps there's an issue there.
Yes, I saw a quote in there that someone said that the G Cloud 13 had 5,000 suppliers, as if that was a great thing. And I did sit there and think, look, the last thing that I would want if I was trying to decide where to put my cloud project is 5,000 suppliers to choose from. So I do wonder a little bit if it hurts in some ways to have too open a marketplace that people have to choose from unless you've got clear guidance there for people who are trying to use it. It made me think a little bit of someone I came across a few years ago now, a guy named Mark Thompson, and he talked a lot about government procurement and was talking a lot more about kind of Lego bricks and the idea that really you need to go back to what are the common things that different government departments are trying to achieve and solve the problem by looking at those things in common ways across departments and build up those interfaces in sensible ways rather than focusing too much on the tooling or technology that individual departments were trying to use. And I think there's a bit of that here. Like, it's easy to sit there and criticize and say, look, this is a huge amount of money, taxpayer money. We all want that to be done responsibly. But I'd probably rather at least that they're buying from a service provider that has a little bit of market pressure keeping things working than the kind of giant contracts we've seen in the past for purely custom software or purely custom data center design and things like that. There feels like a little bit more market pressure to keep things under control if you're buying it off a cloud provider.
Well, I think my philosophy on this has always been, if you're using open technologies, you can't really go wrong. So if you're using cloud native stuff, just make sure that it's something that is API compatible or easily portable to something else. So I've said this a few times before, but like if you're using some kind of serverless or managed database technology, make sure that that's compatible with upstream Postgres or upstream MariaDB. If you're using some kind of container technology like Fargate or something, just make sure you're building your containers in such a way that it's not a huge amount of work to orchestrate those using something else, like Kubernetes or OpenShift or something. It does mean that it's a little bit more work to do these things. You can't just point something at DocumentDB or Cosmos or whatever and have some nice managed thing that works for you. But it does mean that you are building the applications in such a way that the real proprietary stuff that you care about, the application code, you still own, and that the orchestration is then portable in such a way that, you know, if you were to end your contract with one particular cloud provider, be it a government organization or not, it's not a huge amount of re-engineering to get it running elsewhere.
Yeah, that sounds sensible to me. I'd be a lot more concerned if people were really wedding themselves to a single provider, whichever provider that was. And I got a huge amount of sympathy. Like, I can't imagine how difficult it is to try and pull all the government departments across the UK into a new technology solution. So I realize this is easy to talk about, but much harder to do, right?
Even if you don't ever move off of that cloud vendor, being in a position where at the negotiating table you can say, we can pull this lever, should hopefully mean that you're getting better bang for your buck for that public spending.
The part of the article that really stood out to me is that this quote here, that they typically experience a 6 to 9 month period costing over 500,000 euros to activate and deploy any cloud environment. And the inefficiencies of having to redo that proves to show that there is a lack of a standardized approach. And that screams to me that they didn't understand what cloud native architecture was at the beginning, or the lack of communication between the 5,000 plus suppliers. Because if you're having to re-engineer your low-level cloud architecture and it takes 6 months minimum to deploy something, That doesn't sound like you understand cloud architecture.
I'm going to come out and say here that you can tell Sean's the American in the room, because lack of standardization across public services is something that the UK really suffers with across the board.
Us too. It's not fair. I'm sorry. But my point stands. How could anybody, be so large with 5,000 plus suppliers and get this job done in an efficient way? I think it's not possible.
Well, I think Amazon famously was very good at this, in that they looked at their size and they divided a lot of what they did in their business into services that they offered for the public. And at the point that you've opened up your services for external use, I think it does keep you a lot more honest about focusing on the tasks you're trying to achieve in your part of that organizational business, rather than trying to solve too many problems in an isolated way or a siloed way across the organization.
Touche.
Time for some admin now. So first, thank you to the existing supporters on PayPal and Patreon. This is part of the Late Night Linux family, so for various amounts on Patreon, you can get an ad-free feed of either just this show or all the Late Night Linux family shows. And if you like the show, please do spread the word. It's important that we find those other people out there who are interested in the private cloud, the public cloud, and everything in between. Also, if you have any questions or any feedback, please send them to us on show@hybridcloudshow.com. So, in the Late Night Linux episode that came out recently, we already covered the XZ vulnerability or the backdoor in quite some detail. And I think there was a reference there back to a security podcast that went into the details. But I was wondering, are there things there that we should be talking about from a cloud-specific perspective, and how to keep your cloud workloads secure in light of vulnerabilities like that, if that's possible?
So I think specifically in terms of SSH, there's a bunch of stuff you can do here, right? I mean, the obvious thing is don't expose SSH to the internet, but cloud providers have got various solutions to this. So from the AWS side, for example, there's Systems Manager Session Manager, which is a solution using AWS Systems Manager as kind of a replacement for things like SSH bastions to get into hosts. And the other cloud providers have pretty similar things as well. Obviously, there's also the thing of just don't expose SSH to the internet.
There's another approach that you can take when you're using these cloud services, which is to make sure that you're abstracting yourself away from managing these dependencies. So rather than having an EC2 instance where you're responsible for installing and patching these things, hand it off to the cloud provider and use cloud provided images or run things on Lambda. So you're not in control of any of these things. So leverage the cloud for what it's there for, which is abstracting away a lot of these problems.
Yeah, I wouldn't say that the clouds are always perfect at keeping their managed offerings up to date, but I think that's right, that if that's not something you're comfortable with, then it is sensible to let somebody else look after it. I think that there are some interesting solutions out there. Azure in particular has done a bit of work that if you're launching new Ubuntu instances through the portal to start with, then they're going to enroll you in managed system updates that do your updates for you. And that's a sort of rolling program that looks at your AZs and all the rest of it to decide how to roll things out across your Azure estate more generally. And again, look, if you're deep in the details of this stuff, you will likely criticize maybe the speed that rolls out or the way that they do that. And if you want to take control of all that, you do it. But I think some of the offerings out there are relatively good at helping you keep your updates, up to date. Now, this didn't even get that far, did it? As far as I understand, on the Ubuntu side at least, it didn't make it into any of the stable releases. And I think that was basically the case across the board. Is that right?
Yeah, unless you're running something like OpenSUSE Tumbleweed or Fedora Rawhide, or Windows, actually. None of this should have ever been even close to any of your workloads.
It's a really tough problem, though, isn't it? I look at all of these things, and they're all good security advice, but I'm not sure that this particular attack or backdoor would have been prevented by doing these things properly. I mean, the other thing everyone's always talking about in this space is SBOMs, the software bills of materials and all of that. But most of that and the secure supply chain stuff is focused on making sure that you've got this secure pipe from the upstream to you as a user. And they're not really designed to prevent you against the upstream. That's a really hard problem to solve.
Yeah, I think there is a certain extent to which you just have to trust upstream, right? And In this case, upstream did catch it before it got into anything that people should be running into production. Maybe next time it won't, but I think if you're using an upstream, you've got to have a certain element of trust there that they're going to do the right thing, whether that upstream is a distro maintainer on the Linux side or the cloud provider that's looking after your managed database instance or your managed Kubernetes cluster or whatever it is. If you're using something upstream, trust they're doing the right thing. And to be honest, you're probably then not the only people who are impacted by it either.
All right, we better get out of here then. So we'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
Thank you, everyone.